Here we have drawn the activity on arrow network diagram for the given problem. Now, it's a good idea to verify from the diagram whether this is correct or not, and for that purpose the approach will be that we can check for activity A there is no immediate predecessor. Similarly, for activity B also there is no immediate predecessor. So we can check it from the table whether for A and B there is any immediate predecessor or not. You can see that C starts from node 2 where A is ending. So for C, A is immediate predecessor. For D, A is immediate predecessor. Similarly for J, F and H are immediate predecessor. So we can see from this diagram what are the immediate predecessors, and we can compare it with the work breakdown structure table, and if it is matching means our network diagram is correct. After that, the question asks that what is the project completion time? We have the activities written here and the activity time written here. So we will calculate the earliest time for all the nodes, and we will see what is the earliest time at node 10, and that will be the project completion time. So the idea here is that for the start node we take the earliest time as 0, and then for node 2 the earliest time will be 0 plus activity time connecting node 1 with 2. So 0 plus 15, 15 is the earliest time for node 2. For node 3 the earliest time is 25. For node 4 earliest time will be 15 plus 20, that gives us 35. So for node 4 the earliest time becomes 35. For node 5, if you see, then here the activity D takes 22 days, and it can start from node 2 where the earliest time is 15. So 15 plus 22, 37, that is the earliest time for node 5. Now for node 6 the earliest time will be 25 plus 20, which is 45. For node 7 we have two activities ending here. So 35 plus 18, that gives us 53, and 37 plus 25, that gives us 62. We have to take the higher of the two because both the activities must be over, then only we will say that node 7 has come, means F and H both are over, and J can start from there. So 62 is the earliest time for node 7. For node 8 earliest time will be 37 plus 15 here, which is 52. Then for node 9 the earliest time is 55, and for node 10 when you calculate it is 62 plus 20, which is 82. 52 plus 25 is 77, and 55 plus 17 is 72. So out of the three we will again take the highest. So the earliest time on node 10 is 82. Now project is considered to be complete only when all the activities are over, and that can happen earliest in 82 days. So project completion time is 82. Now this 82 we got from 62 plus 20, that is from this line we got, not from this or this. So we have to do this activity J in timely manner. So we can say that this will be on the critical path here. Similarly here 62 we have got, this 62 we have got from 37 plus 25, not by 35 plus 18. So H has to be done in timely manner. For F, we may have some extra time in hand, but H we can't delay. So we can say that H also will be on the critical path. So we can similarly connect this here to get the critical path. Then this 37 on node 5, since only one arrow is ending there, so obviously D is on the critical path. And for node 2, again 15, there is only one. It means that activity A, D, then H and J, these four activities form the critical path. Our critical path here is A, D, H and J. Now the question asks that activity A is likely to be delayed by 2 days and activity B by 7 days. These two are start activities, and generally in the beginning of the project all the resources are not available. So here the chances are that activity A may get delayed by 2 days and B by 7 days. Which one you have to address? Are both equally serious, or one is more serious than the other one? Generally, project managers without the knowledge of this technique, they feel that activity B is a long activity, it takes 25 days time. So any delay here, that will be causing more problem. And the question also is saying that B is likely to get delayed by 7 days. So again one will think that this is more serious problem and that needs to be addressed. But now we have seen that activity B is not on the critical path. So if some delay happens on B, then too there will not be much problem. But activity A is on the critical path. So if you delay activity A by 2 days, then you will find that all the node earliest time which we have got on this path, that will be getting delayed by 2 days. So here this will become 17 because of delay of 2 days in activity A. And since this is delayed by 2 days, so 17 plus 22, that will become 39, and 39 plus 25 will become 64, and 64 plus 20, that will become 84, and the project completion time will be getting delayed by 2 days. If you increase the time here on B by 7 days, if this gets delayed, then we can easily observe that here 25, instead of that now it is 32. So on node 3 earliest time becomes 32, plus 20 it becomes 52, plus 10 that is 62, and plus 17 it is still 79, which is lesser than 82. It means that even if activity B is delayed by 7 days, you will be able to finish all these activities up to L by 79 days, and still you have 3 days extra in hand. It means that activity A, delay in that is more serious. Normally any delay on activity on critical path will be delaying the project completion, while for other activities which are not on critical path, some delay is permissible. It will not be delaying the project completion time, but again if the delay is beyond certain level, then it will cause problem. So we will have to check how much delay is permissible. So here A is a more serious problem. Another interesting question here is that there are some resources which become available during project, and that is going to reduce the activity time of K by 4 days, J by 2 days, and L by 5 days. These are the three end activities, and as the project progresses, project manager arranges for some resource to reduce the activity time of the end activities. Now K can be reduced by 4 days, J by 2 days, and L by 5 days. So which one should be reduced? Now you can very well check here that J is on the critical path, not K or L. So if you reduce the activity time of K or L, then that will only finish K or L a bit earlier, but J will still continue and that will get over after 82 days only. So project completion time is not getting reduced. So if we apply resources on activity J and reduce that by 2 days, then that will be reducing the project completion time. Once again, it is not necessary that whatever reduction we do on activity time of critical activities, that will be reflected in reduction of project completion time. That is not necessary because other activities or other paths are also there. So if the reduction due to critical activity time reduces the time of that path below the time of any other path, then the other path becomes critical. So in that case, the full reduction will not be getting reflected in the project completion time. So we need to be watchful if the critical path changes due to delay in any activity or reduction in activity time of critical activities, then we will have to be watchful about that, and accordingly we will have to decide about the project completion time.